Okay, so let me share my screen. So pandas basically, as I think already mentioned this, it's usually a library used in Python. I think should be the most popular actually. It is usually used to make manipulations. I mean, not manipulation, but read data and also try to do some manipulations and even interact with data from the point of data frame. Data frame is a data that is structured, either it's a CSV or series. So that's a data frame or series. So basically, Pandas is the library that is used to ensure that data may be from a file. You can interact with data from a file, either it's a CSV. Um, then we have, so this is just the Pandas, it's called Pandas. I think we have already known how to import libraries. So we started with NumPy, which we did some interactions with, and then now we can go to Pandas, whereby the approach is not different. You only need to know what is the library, your library inaitwaje, and how do you actually deal with it. So yes, just an example, how you create a series. So you can see on the right, we have the output. So you see that this is like more of a, as you can see, when you compare to the NumPy was mostly like an array structure, but this one is now like you're trying to create a more structured data in terms of maybe as a series or in a table format, which we call a data frame. Um, so it's similar to this, but differs in the fact that series associate a label with each element. Basically, you can see like on the left upper kuna 0, 1. So it is like it's assigning index, trying to index is basically like the count from 0, 1, 2, 3, 4, 5. So every element is assigned a particular index, or maybe a label for that matter. So if index is not provided, the user can create index. So the user, you can also predefine your index, for instance. So when you get the propeller, things get interesting because now you are trying to interact with data that is more easy to see, visualize, because it's a kind of a table. We try to open. Let me open the. Let me. I want to open the. What do you call it? Notebook. Okay. So you can see. Let's open a new. Start a new notebook. I'll even use one of these. Oh, this one is already. Oh, then another one. File new notebook. Select. So save as. So we can say this is. Sorry. Rename. Pandas 1. This is part 1, not something. Part 1. So, I see the first thing is always to import the library that you are using SPD. I see that we write SPD so that we can just access the we can access the, what do you call them, the methods or functions in Pandas library using this shortened format. It's just like to shorten the way to access and still have the same access. So this case, so once you got, you can run that. There is no error, so it's fine. So we want to say, let's say create a pandas series. So we say pd dot series. So you can see, I want to see how the structure changes based on what we have been working on with before. So you can see the structure. It's like it's creating a more formatted way, like a table kind of. And you see on the left there is some index. They are assigned automatically from 0 upwards based on the number of values. If I add another one, it will go to 5. So you can see that these are series. So as I mentioned, Pandas series is just one of the, because we are talking of data frames, these are the two main data representations in Pandas: data frames and series. Data frames are basically mostly when you are working with a data set that you have imported, maybe a file. This one is quite interesting actually to deal with. Okay, let's now the other part. Let's go to the other part. So series, we have seen that, and you've seen the label is created on the left, where the label is like this association on the left, or the index kind of. So you can see, um, you can also output the series you've created as values rather than as default. You can see on the right that when you do that, it extracts its values. You can also provide the index manually, like you can see here. The index is already assigned, so you give the index on the left, I mean on the right. So let's try this. Let's try this out. So we're saying that the other thing is you can retrieve values or pandas. So basically what you do is you can say print pandas series, my series up there. You print dot values. So you can see they just retrieve the values. So they represent this one like a list kind of. The other thing is like you can define your own index. Index ni kama hii iko hapa left 0 1 2 3 4 5. So instead of that order, naweza sema but I want my series to be, let's say pandas. Okay, can create another one. Can create another one. So basically here, once we can create another one and just call pd.series. Sorry, just create some from some random numbers. But what here now, instead of leaving the default, whereby the default is this index is assigned by default, we can specify the index. So we can say instead we want, how many values are they? 1 2 3 4 5 6 7 8 9. 9 values. So we can say our index is I can say our index, sorry, something like A, B, C, D, F, G. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5. So you have G, A, B, C, D. Una E, A, B, C, D, E, F, G, H. Just now defining our own index. So this is like now a series with user defined index. So I would print this. Okay. So you can see here, yeah, you may just the new line. So you can see there's the nini, how do you call it? The index on the left has been, we have defined it in my own way. That's what we mean, like you can define your index in pandas. The other thing, I know you have already maybe mostly looked at this, so because I told you to go through it. Um okay, filtering mostly works where you have filtering is where you want to maybe to set a condition or maybe to put a condition how to operate. For instance, if you see it only retrieves values that are meeting the specific condition. So you're saying that for values that are greater than 0, you multiply by 2. I mean, for new series, you set the condition to 2 and you multiply by 2. So basically here you just set in the condition. You can see that filtering and math operations. So like we can see that, let's try that one in what we have. Filtering and series. So let's say we want to filter this, so we can say this series, sorry, this series is equals to this, where the series is greater than 40. I think it's correct like that. Sorry. Let's print and see what happens here. So basically what happens, it's like I've created a filter for this series where the value in the series is greater than 40. So all the values that are below 40 are ignored. So it's like I'm creating a new series based on this condition, that where the values that are beyond 40 are the only ones considered in the new output or in the new series. So that's like filtering basically. Uh Data frame. Now we are getting to more interesting things. So around data frame, so you can see maybe some of you have not done data, but I know you have ever used Excel or you have ever seen data somewhere in Excel. This is mostly like the representation of data in Excel. But now in Pandas, we usually call it a data frame. Data frame is the how it is represented inside the program, but the data still like it's a kind of a tabular format. Only that in Pandas now you have to represent it as a data frame so that you can interact with it using Python. So basically, that's what we mean by a data frame. So it's just like a format of data that is in a format that can be we are saying that it's in a format that you can interact with it for as a table, but now from the Python side. So you can see the data frame is a table, rows and columns. So, but from the programming point of view, each column is a series object. So you can see this column like is a variable name. This is a variable name. Variable name. Rows consist of elements and series. So we have the rows. Just rows are usually these ones. In and IV is the second row. This is the third row. Then columns are the ones the headers. Zenye zinaenda vertically. The columns. So you see how you do that one. So you can actually create a data frame in Pandas, and it will appear as a table. So let's create like some data frame here to see the interesting abilities of Pandas. So let's get to creating a data frame in Pandas. So what you do, you define, let's say we want to create a data frame for people. Let's say it's people, some people data, maybe there. So we say pd dot data frame. Note that D and F are capital. Then here you put that, then you put this. The reason we put the square brackets, this one is just for enclosing the function, but the square brackets are to define the structure. It's just to tell us what we are creating here is either a multi-dimensional thing. Basically, that's why we put the two square brackets. You might be wondering why do we usually mostly put these two square brackets? They are mostly to define some multi-dimensional data, because like a data frame is multi-dimensional. You can rows and columns. That's why we add the two square. We usually add the two square brackets. So here it would say like something like h. So basically, I want to create like a structure like this. That's what I'm saying. So create age and something like age. I want to create this structure. Then we see how it looks like. So let's say age, where people have some just random age values. That's 1, 2, 3, 4, 5, 6. Then we create their height. Let's say weight. Let's say this is their weight is 56, 76. Remember that these values are matching because they will be matched. The number of values here should be the same as the number of values here. So come up and make a 6. This one should also be 6. Then we go to maybe height. It's 1.4 meters or something. 1.7, 1 point. So 1.7, 1.1, 1.8. No other is person wants 2 meters anyway. Maybe they are there. And 1.4 or 6. Okay, something's wrong. What is it? Oh, I should put and close these ones like this. I think so. If I go in quotes. Not yet. Oh, there is a problem here. Let's see there. Age. What is wrong? What is wrong? I think the format is correct, right? Yeah, let's try to. Oh, sorry. I see. For data frame, this one should be nafaa kuwa hivi. Sorry for that. I think they should be like this. They should be the curly brackets. Yeah, they should be the curly brackets. Okay. So you can see, you have created some data actually here. Actually, once you create the data frame, as you are going to see, even when you tukianza kudeal na large data sets, you can even do more interactions. I can say I want to check the description of this data maybe. So I can just say print something like it's in pandas you say that data name as they describe, right? So describe hapo so inakupea, unaona hapo inakupea some description of that data, but we are going to explore these different operations here. Like kama hapo unaona inakuambia kama ni age, the count is six entries maybe, mean ya age ni hiyo, standard deviation minimum 25 percentile, 50 percentile, 75 maximum value for that is that. So it's like you are getting some statistics around the data you have when you say describe, but we are going to see more. For now, you work with some of this. That was just like some catch or some example there. I don't know. You can always ask a question or interrupt before if you have any challenge or understanding something. Um, you can also create it from a list. So if you have a list of lists, you can just convert it to a data frame, and it flows in the same way. The same case you saw, we were converting the list of lists to a NumPy array. So the same approach here works for pandas. So you can see like we have a list of list up and list two. What you do, just say pd.data frame, then you pass the variable that contains the list that you are converting. And that one of course should definitely create for you the data frame. You can add the columns if there were no columns in that data. So basically this is like you're creating a data frame, I think so. You're creating a data frame from a list, and then now you also add in the headers or the columns for that matter. Can do this one also. Try to. So let's say create a pandas data frame from a list. So you can say the list maybe contains let's say it's personal information or something. Just call it person and say maybe you have some random values here. So okay, so we can say person data frame. The data frame for this we can say pd dot data frame is a keyword in, it's like it's a function in pandas library that makes that conversion. So you pass the person list. I think that's correct. So once you do this, you can actually say print, I think so. So you got this. So you can see I've created that. But I can change, instead of having this default, I can say I want to create my own headers instead so that they are not assigned directly. So I can say I want to add in the data frame I've created, I want to say columns in that. So we have the re-entries. So it should be 3 columns. So maybe ni call 1, call 2, call 3. Sorry, that's not. I think should I add this? Oh, it should be like this maybe. Okay. Call 1, call 2, call 3. Pandas. Confirm. I think should be the name. Hmm, pandas.columns. Oh, it should be like this. Oh, okay, yeah. So equals I not that. So this is like I'm assigning columns to this. So see, they have been replaced. Instead, you create your own way to represent that. If you wanted to do the same for the index, you can also always do that. But for now, maybe you don't want to do the index. Then the other thing, can you always take the type of data that you have, whether it's a series. I think you have used the type function for some time, so maybe it's not a new thing. You can always use that. Um, so you can see for this data, if you ask for the index, it literally returns the, the columns. So you can check here and see. So let's say print index of person df data frame. So I can say that. So would say maybe just person dot index. So you can see it starts from 0 to 3, step of 1. So basically it counts 0, 1, 2, 3. There are 3 columns. That's why you see there that representation. To know the columns in your data, you can just print yenye tumefanya pale columns. You see, if you want to know the columns, you can just change this one to columns. Then you know there's the names of the columns that are in your data. They have called 1, 2, 3. Okay. The other thing, next part is this one. Let's see, what is it? Index. I think we see now you define index for data frame, so I don't need to repeat that. We have seen it in the first example. You just add the index if you want to define your own format of the index that you want to see. You want the index method parameter in your function or the data frame function. This one is very important actually. I think good to pay attention here. You might want to access rows, maybe so you can see like this one. You use ilog and provide an index number. So this is like you're accessing the rows. That's one. You can see the output is country. That so basically you want to retrieve values by rows maybe. This one is important. For instance, you might say I want to search. I want to search through the rows and maybe get the values from the rows. Or maybe I want to extract a particular row in my data. Sometimes it works well. We'll see a point where we are tukianza kudeal na data sets where you usually extract the data, the one that you want to train. Maybe you want to extract one column, the last column, and to pick the other columns for other representation. We usually have what we call the training data, whereby you're training a machine learning algorithm to actually be able to make some predictions. So that sometimes these functions are very useful in those contexts, of which we are going to cover them also as we proceed. Um, so, but maybe just to show you here how to retrieve a row using log and ilog methods. So you can say print first row. So here we can just say my person data frame. Let's just use that one for reference. Hii iko hapo juu. Iko hapa. Dot. Sorry, not dot, but ilog. It should be like this. And you say 0. I think that's correct. Unexpected of file. Should I add link? Should I add this? I don't think I should add that. Really. Who's missing? What is missing? be like that. I don't know. It's not sure. Not high lock. Yeah. Data frame. Let's say this. Onto this. Okay. That's fine. So let's done like that. Look 0. That's fine. First row. So it may return the values in the first row. And see it's this, and this. Inakwambia for that one, for that, like the values, what they represent. So that works well. You can also use the lock. Lock works by, you see the index we have defined. When you use lock now, you use the index. So you can, the same case would just work by the index. Like the upper index, we assigned index k, z, which is the same approach literally. Like if I say, can you just copy this? Think lock. You can see this by default in a return. But remember, it's only that because our rows are like this. Remember, naweza kuwa index ni kitu kama abcd or something, or just xyz. So if it is like a number or a letter that is here instead of this, just the continuous numbers. Kama ingekuwa b now ama a, ningeandika a directly. Like I could write the name, what is here. For now I'm picking 0 because we have only that format here. But if I had replaced this index with something like abc, this one would be a, this one would be, this one would be c. So that's what I mean. So yeah. So for now it's just 0 because it's the same basically. To expand the scope, you can even give a range. For instance, let's say I want to extract first and second row. So kama nataka first and second row, I would go, it's like now I would put like a range. Let's say first and second row. First and second row, right? So naeka 0 to 2. I think that's, yeah, 0 to 2, because 0 to 2 in a pick 0 and 1. It doesn't pick the upper range. So ukiangalia hapa, actually, yeah, it has 0 to 1, 2, or 0, 1, because you only have 0, 1, 2. Yeah, it makes sense actually. I can do 0, 1. Yeah, this one picks up to, it actually picks the upper range. Sorry for that. So hii ni kama unachukua rows, and this is quite powerful because maybe you might want to extract particular part of data. Maybe your data is so large and you don't want to use the whole of it. Maybe I just want to extract the first 100 rows and try to test them out. So that's like you use a range to extract. Yeah, so yeah, you can see the slicing works also very well. Filtering, I think to extract, have we come to extract column? Oh yeah, extracting columns is actually now where you do like this. You can say, just show you before I forget. So get columns. So we can say for columns, you can say maybe I want all the rows, comma. So basically inamaanisha, because I have not put the range, it picks everything for the rows. Then I want the first and the second column. Get columns 1 and 2. 1 and 2. And all the rows. So let's see. Oh, what's not talking? says kuna kitu sijaweka vizuri. I should be double, I think. Is it usually a double quote? Sorry. 1, 2, 1, 2. Put this one. What's the? Let's try 0, 1. To show something. Get then. Let's show you. So inachukua all the columns, row 1, 0, 1, and it repeats row 0, 1 and all the columns. If we do this, let's change something. If you do this, inamaanisha you are picking all the rows and all the columns. So you can say get all the rows, all columns, and all the rows. So you can basically do this. Then actually I should be able to get this nini. Let's say what I was trying to get first and second column. I think we can try it out to see what's the problem, and all the rows. So we can say I want to get all the rows, then I want to get, or maybe it's because we removed the index, I'm not sure. Maybe if that's the issue. Let's confirm. Column 2. Yeah, actually that's true. Basically it's saying I'm getting all the rows and then the columns with these labels only. I'm not getting them. So you can see get the first 2 columns and all the rows. So inamaanisha the first one inamaanisha all the rows, then I put a comma, then I put the range of the other columns that I want. So nikiweka, assume like I put like that. So nikiweka that ni kama inachukua the range between these 1 to 3, so inachukua zote. But there could be another case. There could be another case whereby maybe I want to only pick the last column. So let's say get last column, and all the rows. So together, so the first one is all the rows. To get the last column, I think you do -1. Is it what? Negative? Oh, it should be. We put the colon and -1. So I think it's like that. Nini tumekosa? Oh, it's because we have used our nini are not indexed. Maybe we can do. There's a way to do it. Is in the nini the number. I'm trying whether it works. Let me confirm. But kuna venye unaweza get last column of a data frame. I think that should be the case. I don't know why inakata. It's usually like that actually. Don't know why it's refusing. Any question as we continue? DF. Actually, this is usually the case. Okay. It's our series was saying. Maybe we can use iLock. Oh yeah, I think we should use iLock here actually. Is it working now? Yeah, it works. Oh yeah, actually there is a difference between iLock and nini. Let me show you the difference. Difference between lock and iLock. So basically you can see lock and the lock is typically used to label indexing, while iLock is used to index integer indexing. So basically iLock is used in this case because remember we want to return the last element, and we might not actually be no equal, because remember our data inaweza kuwa na so many columns. So the iLog assists you to say I want to get all the rows and the index. Using the integer index, I get the last column only. So you can see here, yeah. Wow, is it? Yeah, that's so this is the iLog. Have I treating it well? iLog actually hakuna hii, I think they should be just like that. Okay, yeah. 0 1 2 4 4 4. Okay, nafaa kuwa tu hivyo. The row, every the row, then -1 as the other parameter here. These things actually they will be very useful in start directing data actually. So you come to see how we use them. I come to see how we use them to do that interaction. Okay. And the other thing, can just quickly look. Filtering, I think we have done filtering into, so you can see like for this case, the filter is being created for country code and square. So it's like you're saying you want to generate a data frame where the value is greater than 10 and retrieve only for the country and square. Actually, let's try out. These are powerful. Assume, let me give you even a real case. Assume like you are given data for the age of people. Maybe the data is even over 1,000 records, and even maybe it has several features. So maybe for that data you only want to know the, based on that data, the people who are above 20. You just want to know maybe where they live, either the location. It's just like trying to see how the nature, how the pattern in the data. Maybe you want to see the people above the age of 20, maybe where they live, maybe the level of education, for instance. So you just retrieve those two rows for that specific category of people, and that's why filtering is very important. It comes in handy actually. So you can say filtering in a data frame. So let's say we want in our data to say print our data frame inaitwaje hapa, person df. So print person df, so we say person df, we pick values from person df. So the first parameter is usually the data frame itself, then the other one is now to set the condition that in the df I only pick maybe values that are above, let's say 30, sorry, that 30. And then what do maybe I just want for only for column 2 and 3, column 2, column 3. So ukiangalia hapa umeona hii value ya kwanza imekuja ikaona hii value ya kwanza is not greater than, yeah, the first value is not picked because it's not greater than 30. Then inaangalia 34, the other, so hii value ndio imekuwa omitted. As you can see, that's the filtering that you're talking about. You can see country square. Okay. So here this should be like that. So basically in a filter inachukua the values that are above 30 and retrieves only for column 3 and 4. So those are some of the filtering that are usually very important in data frame. Remember that these ones we have enclosed with using two brackets, E and I. Basically it's because our data is multidimensional. You can't enclose using one bracket. One bracket is mostly just for a list, but ukianza multidimensional, mostly you have to enclose using the two square brackets. Okay. You can delete columns if you want to. There's usually what we call drop. Most of the things we are actually, tunafanya hapo, once even we started dealing with the real data set, we actually be going to be using them. Like this drop is used so much, especially unapewa data where you want to train it, so you pick the variable, the dependent variable versus the independent variable. So you drop the last variable, which is dependent, and now you create the other data frame independently. So, but you're going to see how that one works. So some of these are very important. The drop, and what we have seen, the ilog, the ilog or the log functions, and also the filtering still. So to delete, we can use the drop. So you can say in our data frame we want to drop this specific column iko na hiyo jina. So you say axis is columns or something. So you can see delete column using what? The drop function. Let's try out to delete and see what happens here. Deleting a column. So what you do here is we say new. Can say our person df is like person df dot drop. Drop is a function dot drop. So you want to drop column, let's say column 2. Let's say we drop column 2. Then I think it's correct. Sorry, drop person dot drop column 2 index. Let's try to drop column 2. Drop person. I think it should work even without this. I don't know. It's not. Something that is missing out. I think this one is not even as well. Person dot drop. And just do it directly. No, I think it will not make any difference. Password df dot drop. Oh, is the name correct? Column 2. Column 2, I think should be correct like that. Column 2. This is. Oh, sorry, I think I misplaced that. Okay. Just what? So what's the issue? Oh, because I'm trying to retrieve the nini. Because I've already dropped that column, so now I'm trying to treat data that does not have the same argument. So you can see what happens here. Okay. Yeah, column 3, column 1. So you have only column. They already removed column 2. I'm not sure. Yeah. What if I say column 3? There's nothing. I think I did the first drop. I think this thing is okay. What happens is it keeps the memory, so it is recognized that I already don't have even those columns. They are already gone. So that's why you see even the columns. These are an empty data frame because for every once I run execute for every of these functions, it actually keeps in the memory that I've already deleted the previous. Um, Reading from waiting to file. So this is now where we come to start interacting with the Python files. That is CSV data. So mostly, just to mention this one as we conclude, actually tomorrow we are going to interact with some data, and even start doing these things now. We are getting some exciting experience. So I have to look for a data set that you will interact with and do a few things with it. So basically that we talk of reading data. So itachukua something like, as I mentioned to you, there are platforms you can just pick some data, maybe Kaggle. I think Kaggle is popular. Kaggle is a free place where you can just pick some data set and try to play around with it. It's not actually easy to find data set that is maybe you can use for data science project, because like even the Kenyan context, we don't have people who publish their data online. Actually, this one, most of the data here happens to be for the in the Europe or the US, American countries. Unfortunately, Kenyans, it's like they don't like publishing their data, which of course is good, because publishing of course assists in further research. So if more data was available in the like in the Kenyan context, the people might be able to do some exciting research around some of the things that are happening. But unfortunately, if you have to do mostly in a Kenyan context, unless you're in a company, maybe you can access some company level data, but some of the diverse data in or the universal data in Kenyan context is not so easily available. It's either people do not like to collect it, or they don't like to disclose it if they collect it. But kuna hii platform inaitwa kaggle.com. It's just one of them. We have several others that you can go and explore. Kuna ingine inaitwa UCI. This UCI machine learning also has some data sets. Data sets are just like you can get some files. Let's say inataka data about things like COVID, or just an example. So unaingia hapa, but here hii lazima ukuwe login. You should create an account basically. So maybe I can just say I want data about COVID. So you can see several people have actually downloaded this one so much. Okay. I can also, maybe we come to download this one. Yeah, this one is large. Huh? Maybe I have to look for a smaller one. Here 20 MBs might take time to load when you are trying to read it to your computer. I think I'll look for a smaller data. That's maybe this one. What about this one? Let's see. This 10 MBs. Maybe it's not that large. Let's see the structure. So sometimes, let's just to give you to explore this environment. When you search for data, hapa kwa search na ikulete. So utaona hapa mahali kuna data set, that's where you search from. Once you search, so you can go and create your account here and try to explore to get data from this place. Once you search, hapa chini unaona some how the data looks like. You have some view on venye inakaa, so that you can decide whether you actually need it or maybe you don't even need it. So ukiona what is happening, like the things or the kind of data that is collected, like hii data, continent, location, date. We have some other things hapa mbele. Unaona hapa new cases, total cases. So ukiona unataka, you click download, inakuja hapa. Then now you come and you start interacting with it. The advantage of this platform is like some people even have written some code, so you can even learn from this environment. Some people have written some code around things that they have worked on, which is very interesting. So that's why I say when we talk of reading data from a file, that's what we'll be doing. So we'll get a file of data, either a CSV, read it, and now start interacting with this. So you're going to see how to you read using the read.csv method. Then you proceed to start the manipulations. So from there now we start what we call the exploratory data analysis, just to understand how the data looks like, do some plotting of that data, create some summaries, maybe the average, the mean, like just try to understand how the data looks like. Yeah, so this is just an example of data maybe, but I don't know whether we're gonna use this one, but we can download even ours. There another one. So you see how do you read data into your environment and start interacting with it. Any question? So this one will be interesting. No, actually we are actually getting to the climax of most of the analytical aspect of what we intended to achieve for this course. So that's why we can't call it off if we have not done what we are going to do from tomorrow. So we're going to interact with it from this perspective, create the kind of plots like these ones, create some visualizations. This is just like trying to understand the data looks like. We can create some advanced visualizations using some of this library. Like Seaborn gives more ability to plot your data. You can see all this. You can see scattered visualization. So these are basically like some of the different things we might want to explore as we move on using some of the libraries that are in Python. This is just to explore the pattern in the data that you are working with. So you can see data labeling, getting the analytics. There are so many different things you can actually do. So it's like the remaining part of here is more around visualizations and creating those analytics. Then as we wide up, as I mentioned, we are going to look into working with a few machine learning models and how they help you make some prediction of the data that you have. So that means like next week you should be done basically. Because once we cover this one, tukianza na hii kesho, we cover a bit of it. Then maybe you can also go and try with a different data set once we cover with the one that we are going to do in the session. And from there now we can pick a few machine learning algorithms and you see how you will use them in data science, maybe to calculate and also to create what we call the machine learning models and maybe make some predictions on the data that you have, how likely they are able to predict when they come across new data that is related. That's basically what we talk about algorithms. So you train them with the data that you have, so that when they come across another data that is similar, they are able to decide to make a decision or give some um, inference on it. Any question on for today? Swali.